Hello and welcome back. We'll continue our class of soil mechanics. And in this video, we will start a new chapter, chapter number 5, which is about classification of soil. Okay. So in this chapter, we will learn about this point, of course, introduction and textural classification of soil, classification by engineering behavior, and this one AASHTO classification, which is American classification, and unified soil classification system. And the last point will be comparison between the two previous system of classification. Okay, so this will be about this chapter. In this video, precisely, we will talk about mainly maybe the 3 points. Introduction to point number 3, classification by engineering behavior. Okay, let's go with the introduction. So soil classification system. This is like, these are tools that geotechnical engineers are using to categorize different type of soil, describe and categorize different type of soil based on the property of these soils. Okay, it's like a code, communication code for engineers. Okay, so this system provides standardized way of communication. That what I was saying. Communication, a soil characteristic, without the need of description, too long description. We don't need. If you say one code, it means if you say, for example, like one classification, all engineers should know what is the meaning, what are the characteristics of that soil by just saying the classification of that soil. Sometimes it even imply a lot of things, including the behavior of that soil, the particle size distribution, and the plasticity of the soil. Okay, so that is the role of this classification. This is why we need classification of soil. So there are several systems of classification that exist, but there is no universal classification system. Okay, because there is no system that can cover everything, all soil types around the world. Okay, so in general, the system are classified in two major categories. Mainly, the first one is the textural classification. That one is based only on the particle size distribution of the soil, including the percentage of sand, silt, and clay size fraction of the soil. Okay, that one is an example of that kind of system in this chapter, in this video, sorry, is the one developed by the US Department of Agriculture. This one, USDA, US Department of Agriculture. They developed classification system based only on the particle size distribution, nothing else. Okay, the other one is engineering, geotechnical engineering based behavior classification. So these are based on the behavior of the soil. Okay, and this category is considering not only particle size distribution, but it considers also the plasticity of the soil. Okay, size, the particle size distribution I hope you know what I'm talking about. We have talked about this in the previous chapters. And plasticity is just the chapter 4 we just finished. So this type of classification is using both particle size distribution and plasticity of soil. Okay. And this plasticity of soil, if you remember in the previous chapter, these are determined based on the liquid limit and plasticity index. These two play a very important, these two of the plasticity of soil, these two soil parameters, liquid limit and plasticity index, are mainly used for this classification. Okay. Okay. And based in this category, two widely used classification doesn't mean that there are only two. There are many, but in this chapter, in this video, we will talk about mainly two in this chapter. First one is the one developed by American Association of State Highway and Transportation Officials. This one, AASHTO. And the other one is the Unified Classification System. Okay, so this one is providing guidelines for classifying soil based on their engineering behavior. And in this chapter, we will explore the detail how soil are classified according to this system. Okay, so mainly two main categories: the structural one and category 2, engineering behavior classification. And this engineering behavior classification, we have several, but here we will focus on two. This one, the American Association of State Highway and Transportation Officials one, and the Unified Classification System. Okay, so mainly in this chapter, we will talk about three classifications. This classification, this one, and this one. Okay, so the point number 2, then we go with this, the textural classification system. Sorry, the textural classification system. That one, that's a system. And the soil structure, the soil texture is determined by size of its particle, which can range from gravel, sand, silt, clay. But normally natural soil contains mix of these soil particles. Means natural soil, you can find mix of gravel, sand, silt, and clay, or three of them or two of them. Yeah, it's very rare that you find the 100% one of them. A soil made at 100% with one of them. So there are various organizations that have developed their own classification system over time, but the one developed by US Department of Agriculture system is, which is relying on the particle size. We saw this in chapter number 2 here. That one is widely used. Okay, so it is this one. So in this classification, all soil that has particle size diameter higher than 2 millimeter in size is classified as gravel. So between 2 to 0.05, sand. From 0.05 to 0.002 millimeter, silt. And smaller than 0.002 millimeter in diameter is clay. Okay, there is something very important here. See size number, sieve, the sieve number 10, US system. This one, the 2 millimeter opening. Okay, so we check the passing of this sieve number 10 to see if it contain any gravel or not. Okay, if everything passes this sieve, it means everything is, we don't have gravel in our soil. It means, okay. 2 mm opening on sieve number 10. So we better keep this in mind, sieve number 10. Because this classification is not made for gravel. The US Department of Agriculture, it's mainly using sand, silt, and clay. Okay. So this classification, the textural classification system, which is shown here, this figure is explaining this. As I was saying, it's using clay, percentage of clay, percentage of silt, percentage of sand. We don't have gravel here. Okay. So everything that is retained on the sieve number 10, which is opening size 2 mm American standard, is not included in this classification. Okay. So the US Department of Agriculture categorized soil based on the dominant particle here: sand, clay, silt clay. Mainly this. But we will see that somehow we can include also gravel in the name. But mainly you can see sandy clay loam, and here sandy loam, silty loam, silt. Here, this upper part is mainly clay. Clay is dominant here, and sand is dominant here, and silt is dominant here. The triangle. The upper one is clay. This angle is mainly dominated by the sand, and here by the silt. So to determine, we need to do at least one example to show you how it works exactly. Okay, so if we consider a soil A, which consists of 30% of sand, 40% silt, and 30% clay size particle. I hope you know the meaning of this now, clay size particle. So if you have something like that, what you do? The sand, 30%. So sand is here. Percentage of sand. Can you see this part? So it starts here from 0 to 100%. Okay. So if you come 0 here, it means you have to read this way. This way. It's important to start from the beginning so that you will not confuse. So that, because some people will come and read sand here. No. Okay. For example, if you take 30% and you read it here and you go this way, no, don't do that. The easy way for you to understand which way you have to go is when you come from 0, for example. See 0, you cannot go this way. 0 is telling you that you have to go this way. So you know now that for sand, you have to read in parallel to this line. Okay. So for sand, in this line. So 30%, you come 30 here and you go this way. Okay. That is one. 40% for silt. So silt is here. The percentage for silt is here. Same, we go for 0%. 0% is here. And then you can see this line. You follow the parallel of this line. But you go for, you search for 40%. 40 is here. Then you go parallel to this line. Okay. Parallel. Don't go this way. Because 40, you can go, some people will go 40 here and they will go here. No, this is for sand, for clay. So to not confuse yourself, start from here 0 and try to draw following the parallel of this line like that. So 40 will be here. So you can draw it in this way if you want. Okay. And last one is clay size particle. So 30%. Okay. Clay percentage is here. So same as previous, the previous two sand and silt, start from 0. Okay. 0. So this line, you need to be parallel, going parallel to this line. And you go to search for 30%. 30 is here, and you have to be parallel to this line. So 30 will be. So as you can see, the three arrows will meet here. They are meeting here. So means your soil is A is here, classified here. 30% of sand, 40% of silt, and 30% of clay or clay sized particle. So in that case, you can say that according to this classification, your soil is clay loam. This because everything that falls in this K is classified as this soil, clay loam. So as a geotechnical engineer, if you say that the soil you have on the construction site is clay loam, then one should know what kind of soil it is. Okay. So don't forget also that this chart, this figure, this classification focuses on the fraction of soil that passes through the sieve number 10. Do you remember sieve number 10? I told you in the previous slide that this sieve is for the soil particle smaller than 2 millimeters. So everything passing through this sieve means if the soil, every soil passing through this sieve number 10 means that the soil has soil particle with diameter smaller than 2 millimeters. So it means it will be automatically be sand or clay or silt, only these three. So let me go back a bit to show you what I'm talking about in the table we discussed in the previous slide. Here, okay, this one, sieve number 10, American standard, it means 2 millimeter. 2 millimeter. Everything's higher than diameter higher than 2 millimeter is gravel. So if the soil passes this number, it means the soil has to be these three, the only possibility of the soil, according to this classification. Not here, sorry, it should be here. It's very clear, okay? Yeah, so this classification concerns only this sand, silt, clay. It means soil, the portion of soil passing here, smaller than 2 millimeter, means the soil passing the sieve number 10 of American standard. Okay, let's go back. Okay, I think we were here. So this is what we are talking about. This one is only sand, clay, silt. So if soil now contain particles larger than 2 millimeter in diameter, in that case, you need to correct. We need correction to be able to use this chart, to use this classification, okay? So I'm going to make one example using the correction so that you can understand what I'm talking about. For example, if we take this soil B, this soil B has 20% gravel. See, there is no gravel here. 10% is sand, 30% silt, and 40% clay. So we have to modify this so that we can use this chart. How to do that? For sand, the modified percentage of sand should be, you take the percentage of sand here, it's 10%, right? 10% mean 10 multiplied by 100, and you divide by 100 minus the percentage of gravel, 20. Okay, you see percentage of the sand here, percentage of the gravel, because we want to, here will be always percentage of gravel. So we obtain the corrected percentage of sand will be 12% instead of 10. For silt, see 30 here is the percentage of silt we have, and the 20 is always in the bottom. The denominator is the percentage of gravel. We'll have 20 here. So the corrected percentage of silt will be 37.5%. And we do also same for the clay size particle. It will be 40 here and still 20 here. 40 because we have 40% here. And you can obtain the corresponding, the corrected percentage of clay size particle here, 50%. So now you have to use these 3 percentages to classify your soil by using this method. Okay, so for the sand, by using that, based on the modification, for the sand, 12%. You remember what I said? Come here to 0, you can see that you have to be parallel to this line. So 10 is here, so 12 will be here. 12, you can draw a line here if you want, if you wish. Okay, then that is for sand. For silt, you come here, silt is here, so 0 is here. So you have to be parallel to this line. Okay, so you search for 37.5. So around, it will be around here. So this line, approximately, okay? Don't judge me because I'm not really good. So you can do it approximately. And clay fraction, clay size particle, the percentage is 50%. So this percentage, clay 0 here, so you know that it has to be parallel to this 0. Okay, 0 line. And you search for 50, it will be about this. So the 3 lines will meet here. So it means your point B is this here. And if you see this block here, see, what should it be? As you can see, this block, all soil that falls in this block will be here, clay. Okay, that's why according to this US Department of Agriculture classification system, we will have this B soil will be clay. Okay, but because this soil has a considerable percentage of gravel, in that case, we can call this soil B as gravelly clay because of the high percentage of gravel. 20%, it's not small actually. Okay, yeah. Then I think there are several other structural textural classification system. Okay, but they are no longer in use for civil engineering purpose. This one is mainly the main one using. So I think everything concerning the textural classification system, you know. So I hope if we go for few more examples, you will understand more and you will be able to do it alone next time. Okay, so I will take one example. For example, with classification, if we take this soil, we have A, B, C, D, 4 soils. Okay, and you are asked to classify these soils following the US Department of Agriculture classification system. Okay, what should we do? So as you can see, soil A, B, and D, these 3 soils, they have gravel. And as we mentioned before, the classification doesn't take care of the gravel percentage. In that case, you have to make correction. However, for the sea soil, you don't need to correct anything because sea soil doesn't have gravel, 0%. Okay, so the first step you should do is to modify the percentage, to correct percentage. So I'm giving the formulas here. So percentage of sand multiplied by 100. On the previous slide, the 100 was here, divided by 100 minus percentage of gravel. Percentage of gravel should be always here in the three case, the three equations. Okay, so percentage of gravel, for example, if you take the case of this soil A, percentage of gravel is 12. So you will have 12 here, 12, 12. Okay, for the same soil A, the sand is, the percentage of sand is 25. So sand, you put here 25. For silt, 32. So you put here 32. Clay, it's 31. So you put here 31. Okay. You do the same for the soil B. But considering that in soil B, the percentage of gravel is 18. So you have to put 18 here, 18 here, 18 here. Okay. And check the percentage of sand, which is 31, percentage of silt, 30, percentage of clay, 21. For C, you don't need to do that because C doesn't have, even if you do, you will get the same percentages. It will be just 0. You don't need to do that for C because it will be, how to say, minus 0 here. So 100 and 100 here will be simplified. You will still get the same percentage. So it's just waste of time. Don't do it for if the percentage of gravel is 0. And you can do also for D. So after doing that, you can obtain these new percentages. You see in this new table, I don't have gravel. I deleted the percentage of gravel. Okay. So sand for soil A, it was 25, now 28.4. Silt was 32, now is 36.4. Clay was 31, now is 35.2. Okay. So B, soil B, here, no more gravel, okay? 31 became 37.8 and silt 36.6, clay 25.6. As you can see for sea soil, nothing changes, okay? 15, 30, and 55. D, it changes. 22 becomes 25. 26 becomes 29.5. 40 becomes 45.5. Okay. So, and then you use these percentages for each soil. You use the chart, the previous slide. I'm not going to do that. I hope you can do it by your own now. Okay. Let me go back to show you what I'm talking about. I'm talking about this chart. Okay. I have already explained you how to use this. Just use it for each soil here. We have here in this table. Okay. And you can classify each soil according to the chart. We will have gravelly clay loam, and clay, and gravelly clay. So why we have gravelly here? Because of these three soils contain a considerable percentage of gravel, 12, 18, and 12 here. That's why. So the clay loam is what you obtain on the chart. Loam here is what you obtain for soil B on the chart, and clay for soil C, clay for soil D. But since soil D contains 12% of gravel, we will say gravelly clay. This is how this classification works. Okay, so for this classification, we are done, and I think there is nothing you cannot do about this classification. I hope you have understood everything about this classification. So let's move to the third point of this chapter, classification by engineering behavior. So as I say, this classification includes not only the size distribution, particle size distribution, but it includes also the plasticity of soil. Especially, we need liquid limit and plasticity index. These two parameters we have talked about in the previous chapter. Okay, so let's go. It will not be long, this section actually, very short. So classification by engineering behavior. So while this textural classification of soil is based on particle size distribution, is straightforward method, it has its limitation. So for that, because of that, we need other type of classification. So it doesn't take account the presence of clay mineral. And according to the previous chapter, clay mineral can play a very important role in the soil behavior. Because clay mineral, if you have water, you have to be careful sometimes because of the capability of soil of clay to change behavior according to the presence of water. So we have discussed all this in the previous chapters. Okay, so the classification doesn't take account this clay mineral behavior, presence of clay mineral, which is significantly important for physical property of fine-grained soil. And clay mineral also contribute to the plasticity, which is also another important factor in understanding the soil behavior. Okay, so textural classification system slowly based on particle size distribution is insufficient for many engineering purposes. So to address these limitations, two more comprehensive classification systems are commonly used by soil engineers. Okay, so we have American Association of State Highway and Transportation Officials, this one, AASHTO, and also the classification system and also the Unified Soil Classification System. These two will be discussed in this chapter 5. Okay, mainly. I mean, this one, the first one, as the name indicated, American Association. This one is mainly for American. And this is universal, unified soil classification. I think this one is used everywhere. If you go in other countries, you will see that they are using maybe different classification system. Okay. So both systems consider not only the particle size distribution, but they consider also the atomic limit, and they give very important information on soil plasticity and soil behavior. Okay, so while this one, AASHTO system, the American one system, is mainly used by American state and country highway department. Okay, this department is using this one. But geotechnical engineer generally they prefer unified system due to broader applicability and the robustness of this system. Okay, yeah, I think that's all for this video. So let's see you next time in the new video to continue this chapter. Thank you very much for your time and see you next time.